Today we are learning another method on how to solve linear systems. Today's method is going to be using determinants. Determinants is probably the first method that we talked about that's not going to be review for you. So this is going to be a new method, new to you. And first we've got to find out how to find just a determinant, and we're going to use these determinants to solve the system. When you are finding the determinant, you are going to multiply the top left times the bottom right. So in this case it's AD, and then you're going to subtract the bottom left times the top right, which is CB. So to find a determinant, you're cross multiplying and you are subtracting them. The order in which you subtract them does matter. So again, first you multiply the top left number by the bottom right. That's going to give you your first product. Then you're going to subtract the product of the bottom left, and you're going to multiply that by the top right number. So for example, we're going to have 2 times 9, and we're going to subtract 6 times 5. 2 times 9 is 18. 6 times 5 is 30, so the determinant of this matrix is a negative 12. If I look at the next one again, we're going to do top left 5 times 2, order does matter, and you're always going to subtract the other product, which is 4 times a negative 3. So now we've got 10 minus a negative 12 minus a negative. In this case, our determinant value is a positive 22. And this is where the majority of the problems are going to come into play. You are always subtracting, so make sure that you're writing your pieces down very, very carefully, and that when you subtract a negative, you end up adding that number. Alright, so now how to use these determinants in order to solve a system. Well, first, your system must be set up in standard form. And standard form is the form that we use for elimination. And again, you want to make sure that your x's are lined up, your y's are lined up, and your numbers are lined up on the right-hand side. Then what we're going to do is we're going to make 3 matrices. Those 3 matrices are going to be the D matrix, the n sub x, and the n sub y. In just a few minutes, it's going to make sense why we have these letters and why we're using these combinations. When we start with the D matrix, what we're going to use are the x coefficients, 4, 2. We're going to use the y coefficients, 3, negative 3. So the first matrix you're going to set up, you're going to use the x coefficients and the y coefficients. Once you have that set up, you are going to find the determinant of that matrix. So we've got 4 times a negative 3. Write down your subtraction sign before you forget. And then 2 times 3. So we've got a negative 12 minus 6, giving us a determinant value of a negative 18. Okay, instead of thinking D stands for determinant, which is probably your first instinct, think of it as standing for denominator. And we know that the denominator is the bottom of the fraction. Okay, then we're going to move on to our second matrix, which is our n sub x. Now n sub x, I am no longer going to use the x coefficients. That fact that it says n sub x, that means I replace x, and I'm going to replace x with our solution set of 16, 18, or 16, 8. The y's are still going to stay there, so it's still going to be a 3, negative 3. So n sub x means we replace the x coefficients with our solution set. We still find our determinant though, so we've got 16 times a negative 3 minus 8 times 3. 16 times negative 3 is a negative 48 minus 24, and that gives us a value of a negative 72. So again, n sub x means we replace the x coefficients with the solution column, and we're going to keep the y coefficients in that second column. They're not going to move. We just replace what was there with the x's. And n sub x is going to stand for numerator of x. And we know the numerator is the top of the fraction, just in case we forgot. And we have one matrix left, and that is our n sub y. So if you thought n sub x was replace x, n sub y is replacing our y's. We always refer back to our D matrix, so the x's are going to stay where they were, the 4, 2. But instead of having those y's there, we're going to replace the y's with the solution set of 16, 8. So the D are the x coefficients, the y coefficients. N sub x means you replace the x's with the solution set, but the y's stay as is. The n sub y, the x's stay where they were, and you replace the y's. Okay, now we've got to find the determinant. 4 times 8 minus, don't forget the subtraction, 2 times 16. So we've got 32 minus 32, giving us a value of 0. Alright, so we have our three matrices. Again, n sub y, we replace the y coefficients with the solution column and keep the x coefficients in place. And I bet you can guess that n sub y is going to stand for numerator of y. Alright, so we have all of the pieces to our puzzle. We've got to put them together. We know we have the d, the n of x, and n sub y. Well, d stands for denominator, so that's going to be on the bottom of both of our fractions. So both of our fractions are going to have a negative 18 on the bottom. Our x, we're going to use our numerator for x, and our n sub x in this case was a negative 72. And for our y coordinate of our system, we're going to have the numerator for y, which we found was 0. A negative 72 divided by a negative 18 is a positive 4. 0 over a negative 18 is 0. So our solution is 4, 0. It seems like a lot because it's brand new, but it's actually really easy once you get the hang of it. Alright, so our second example, on the back page, we look, our x's are lined up, good, but our y's are not. Our numbers are not. We've got to rearrange them so that they're in standard form. So we've got 2x, we've got to move that 4y over, so it becomes a negative 4y. We've got to move the 4 to the right, so it becomes a positive 4. Same thing with the second one, our x is in the right spot, move that y to the left, so it becomes a negative y. Move the negative 2 to the right, or it becomes a positive 2. It is extremely important that you have the x's and then the y's and then the numbers, so it must be in standard form. D matrix. D matrix is the x coefficients. Now there's no number with the x. We know that's a 1, so this is 2, 1. Our y coefficients, which are a negative 4, negative 1. We'll come back and solve them in a second. Now n sub x means we replace the x's. So we're no longer going to have those x coordinates of 2, 1 there. Instead, we're going to replace them with our solution set of 4, 2. So the x's are gone, the solution column's there, but we're not going to change the y's. So the y's are still going to be a negative 4, negative 1. N sub y means we replace the y's, which means the x's stay, and the x's were 2 and 1, but instead of having our y coefficients, we replace the y with our solution set of 4, 2. Now we've got to find the determinants of all these pieces. 2 times a negative 1 is a negative 2, minus 4 times a negative 1 is a negative 4. Minus a negative, I have a D matrix determinant of 2. For our n sub x, a negative 4 minus a negative 8, that gives us a positive 4 value. And our n sub y, 2 times 2 is 4, minus 4 gives us 0. So our x's and our y, we've got to find our x and y coordinate. Again, our D stands for denominator, so that's on the bottom of both of our pieces. N sub x means numerator for x, so it's going to go on top for our x coordinate. N sub y, that's going to go as the numerator for our y. 4 divided by 2 is 2. 0 divided by 2 is 0. So in this case, we have coordinates 2, 0. Alright, next one, number 3. We have our x, our y, our number. First equation is good. Our second equation, not so much. We've got to move this y over. So again, we've got to make sure that everything is set up perfect before we start. So we move that y over where it becomes positive, and 7's already where it belongs. What I want you to do now, press pause and see if you can just get the matrices set up. Can you set up the right numbers for D, the right numbers for n of x, the right numbers for n of y? Press pause. Don't cheat. Alright, check your answers. So your D should be -6, -3. The second one should be 2, 1. N sub x is a -8, 7, 2, 1. N of y is -6, -3, -8, 7. Now some of you may have also gotten rid of the negatives with the first one because yes, technically standard form you have no negatives. That's fine as long as everything else is the opposite. So what I want you to do, right now we just finished the first part of the battle. Now I want you to see if you can find the determinant correctly for each of your 3 pieces. So press pause again, find your determinants, press play once you've got your values. Alright, when we cross multiply for D, we get a -6 minus -6, which is 0. -8 minus 14, -22. -42 minus 24 gives us a -66. So when we plug these in, D is the denominator, so that's the bottom of both of our fractions. Numerator of x is -22, numerator for y is -66. Well, if I have -22 over 0, when 0 is under, it is undefined. Undefined, which means we have a problem, which means we have no solution. So again, no solution, it means we must have had parallel lines to start with, so there's no intersection point, therefore there's no solution. In our problems using substitution elimination, we would find this when our variables canceled out and we have no numbers, or our numbers left are not true. So again, if you have undefined values for x and y, then you're going to have no solution. Last one, example 4. So example 4, we've got our x, our y, our number, our x, our y, our number. Our only problem is we can't have fractions. We want to get rid of our fractions. So we look at the denominators and we multiply by the least common multiple. That way we'll get rid of all of our decimals and all of our fractions. So I've got a 3, 3, and 6. So the number that I'm going to multiply to get rid of all the fractions is 6. So our first equation stays as is. Our second equation becomes 6 times 1/3 is a 2x. 6 times a -2/3 is a -4y equals 4. So again, what your goal is, start by setting up your D, your n of x, and your n sub y. Press pause. When you're ready, press play. Alright, looking at our D matrix, remember it's the x coefficients, the y coefficients. Our n of x, we replace x with our solution, but we keep our y's. Your n sub y, you keep your x's, but you replace your y's with the solutions. That's going to be the pattern every single time. Now that you have it set up, press play again and see if you can correctly find the determinants for each 3 of these pieces. Alright, for our D, we get 4 minus 4, which is 0. For n of x, we get +8 minus +8, which is 0. -4 minus a -4, which is a -4 plus 4, which is 0. So our D, our bottom is 0. Both of our numerators are 0. That means everything is canceled out. Everything was the same, everything is gone. And when that happens, we have infinite solutions, which means we have the exact same line on top of each other. So we've got infinite solutions. So if you have your D being 0, but you've got numerator values, it's no solution. If everything zeros, then that's infinite solutions. Alright, so that is your determinant method, and I know that determinants are new to you, so make sure that you've paid close attention and taken really good notes and being ready for tomorrow.